let's recall from last time that a graph passes the horizontal line test, abbreviated HLT, if each horizontal line intersects the graph at most once. So that is, a horizontal line can intersect the graph once or not at all, right? And last time we saw the connection between these things. So a function is one-to-one if and only if the graph passes the horizontal line test, if and only if when you diagonally flip, the new picture passes the vertical line test. So that diagonal flip switches horizontal and vertical, or switches x and y. So that's why prior to flipping, the HLT means after the flip, VLT. So how do you build geometric intuition of what's going on with the diagonal flip? Well, this is just like, let's think about this. How do you do anything? You've got to practice. I know that sounds silly, but you really need to practice on your own. There's only so much of me just saying, oh, you've got to do this, right? So to be a little more practical with how to practice, think of what happens to one point. So think of where one point ends up after the flip. And if you can pay attention to what happens one point at a time. This is a slow process, but it's the only workable process. Think about what happens to one point at a time, then you can see what happens to an entire graph. And use the little mini flashcards, draw on those to help. Or if you don't have those, you can just, if you don't want to print those out, you can just use any paper that you have. Just draw on paper and then hold the upper right and the lower left corner of the page, and then rotate that, and then hold that up to the light. Maybe if it's a slightly sunny day or something, you can hold up that sheet of paper to the light or up against a window, or if it's not as bright outside, you can from outside hold it up to a window on the inside where you have some light, or just even while just indoors, just turn on a light somewhere and then hold up the sheet of paper in the air towards the light, and you can see what's going on. It is important to practice this. This is not something that's going to come automatically. It's going to take some work. So, as an example of what we mean by think of where one point ends up at a time after the flip, if you have the point 49, 7 on the pre-flip graph, then once you flip, you're going to have the point 7, 49. X and Y coordinate will change. And you should try this. Go draw the point 49, 7, so way further to the right than it is up. And then if you flip diagonally, you'll have the point 7, 49. Now on the mini flashcards, or on little sheets of paper or whatever, you should practice at least with these four graphs. So graph pre-flip, y equals root x, graph y equals x squared, graph y equals x 2 to the x, and graph y equals x to the 3. Right? Try drawing those. Diagonally flip. Prior to diagonally flipping, actually you should just predict on paper what you should get. Draw a picture of what you think you should get prior to diagonally flipping, and then diagonally flip, actually do the action, and then see if the picture that you drew as a prediction is accurate to what actually happens when diagonally flipping. Now, the key story we saw last time was that the graphs of f and f inverse are diagonal flips of each other. Diagonally flipping, by the way, swaps the x and the y coordinates. So if you diagonally flip just one point at a time, the point a comma b goes to b comma a. So let's practice this idea. Even with this kind of really spotty looking graph of a bunch of points. So the point is, there's a point 4 comma 2 here, this point here, which is on the graph of f, and that means if you diagonally so this means, by the way, just to review, that f of 4 is equal to 2, f of x coordinate equals y coordinate. But then it means that if once you diagonally flip, then swap x and y, so then the point 2 comma 4 is on the graph of f inverse, and therefore f inverse of 2 is equal to 4. Now diagonally flipping, again, the point a comma b goes to b comma a, and so let's actually now answer the following two questions. So here, let's say down here is the graph of f. We'll find f of 2, and we'll find f inverse of 2. So for f of 2, we're looking for a point in this picture where the x coordinate is 2. There should only be one place where that occurs, and that's right here, of course. Now, there should only be one place because of the vertical line test. So the one place, when you draw a vertical line, the only place where the x coordinate is 2 is this point right there. And so f of 2, to answer that first part, f of 2 is equal to 5 because of the point 25 on the graph. What about f inverse of 2? Well, now we need to look for where the y coordinate is equal to 2. Okay, so the thing is, f inverse of 2 is equal to 4 because of this point right here. So to break this down, f inverse of 2 is equal to 4. We're looking for a point where the y coordinate is now 2. Okay, we're going to explain this in different ways with different problems in a moment. But f inverse of 2 is equal to 4 because, look, there's a point 4 comma 2 right here on the graph of f, and that means on the graph of f inverse, you've got to swap. So instead of 4 comma 2, you have 2 comma 4 on the graph of f inverse. We didn't draw the entire graph of f inverse, but if you take this picture here and you diagonally flip, there will be the point 2 comma 4 in the graph of f inverse, and that's why f inverse of 2 is equal to 4. Let's try another one of these. So looking at the graph here below, let's find f of negative 3 and f inverse of negative 3. So f of negative 3 is given by this point right here. Yeah, so the x coordinate is negative 3, the y coordinate is negative 1. Yeah, so f inverse of 3 is negative 1 because of the point negative 3 comma negative 1 here in this graph of f. Now what about f inverse of negative 3? So f inverse of negative 3 is given by this point right here. Okay, so the point is that there's this point negative 3 comma 5 on the graph of f inverse. We've kind of inverted how the language looks. Okay, maybe we'll start backwards here. So in the graph of f, which is shown here, the graph of f has the point 5 comma negative 3. Yeah, that's this point here. And so then that's f, the graph of f, but then the graph of f inverse needs to swap the roles of x and y. So 5 comma negative 3 on f is a point negative 3 comma 5 on f inverse. That's what this first language here, the point AB goes to point BA with the diagonal flip, is trying to talk about. And if you have the point negative 3 comma 5 on the graph of f inverse, then f inverse of negative 3 is equal to 5. Let's take a look at the following. Suppose that the graph of y equals h of x is given below. So you've got these 1, 2, 3, 4, 5, 6 points. Then based on the graph of h, shown here, what is h inverse of 2? That is your interactive question. Okay, so based on the graph of h here, how do you get h inverse of 2?